Alrighty, so today I want to talk about physics, and I'm going to be talking about momentum. So first I'm going to start off with the equation of P equals mass times velocity. And so this is the equation to calculate, I'm going to write momentum. This is the equation to calculate momentum. And so momentum is P, and it's calculated using mass and velocity. So what unit is momentum in? Well, mass is measured in kilograms, and velocity is measured in meters per second. And so the brilliant way that we come up with a meter or a unit system for momentum, it is kilogram meters per second. And so that's what all our momentums are going to be measured in, is kilogram meters per second. So one of the questions we were asked in our physics course was, can you have a negative momentum? And the correct answer is yes, you can have a negative momentum. Why? Because we have this velocity quantity. And if we have a positive velocity going in this direction, and then we change direction, yeah, we're going to have a negative momentum because our velocity is negative. And the momentum is made up of our velocity and our mass. Alrighty, so the next thing I want to go over is solving momentum equations. And by kind of solving momentum equations, just kind of attacking it from a theory kind of state of mind of what's going on. So we have the law of conservation of momentum. And I know I spelled momentum wrong, but that's okay. And so basically what this is saying is, and kind of the way that we're going to use it, or I've used it in class, is that the momentum of one thing, so let's say I have a ball and I have a block. And the block, or the ball is ran into the stationary block. What happens next? Well, we can calculate it out. So I'm going to have the momentum of the ball. I'm going to have the momentum of the block. And that has to equal the resulting, or prime, momentum of the ball plus the resulting momentum of the block. So if we have these resulting things here, and so then we can start to plug in stuff. If we had an event, so if the ball weighs 5 kilograms and the block weighs 50 kilograms and the ball is moving at 5 meters per second, then we can start to fill things out. And then let's say when the ball hits the ball and the block move off together. So the ball and the block, they become lodged together, and then they're both moving together. So the velocities afterwards, so remember these p primes and v primes are made up of m's and v's, or masses and velocities. So the velocity of both of these things after will be the same. So then I'm just going to have the prime velocity times the mass of the ball plus the mass of the block. And then that's going to equal the mass times velocity of the block, which is going to be 0 because the block is not moving. And then the momentum of the ball, which is going to be the mass times the velocity of the ball. So the mass times the velocity of the ball over the mass of the ball plus the mass of the block, and that's going to equal the velocity that they're moving at afterwards. So just kind of this process of, this is what I know, and I know they have to be I know they have to be equal before and after their interaction. And so by using that, then breaking it down into the information we do have, canceling out the information that we don't have or don't need, and then solving the equation based off that to get a number. And so that's kind of the general idea of what to take when solving momentum problems.